Hi everyone, I wanted to make a video that went over the practice problems that are included at the end of our lecture this week. Instead of doing a regular activity intro video, I thought that it might be helpful to do a more extensive video of the practice problems so that you get to experience how each type of factorial ANOVA is run, and then use the information from this video and apply it to the examples given in the activity. So again, we're kind of working towards less handheld work and more application of concepts learned. A lot of the stuff that we're doing this week is repetitive of stuff that you've seen before, so hopefully what I go through isn't going to be super foreign. But what I've done is I've created a list of questions that I think are going to be helpful for you in kind of the process that you'll use to weed out information from each of these different types of tests. And it's a very similar process that we've used so far with regular one-way ANOVAs, right? We're just adding an independent variable for two-way ANOVAs. So we'll start with practice problem number 1. It says we're interested to see how much of an effect frequency of practice has on archery score for novice and intermediate archers. So this statement right here is our research statement. Okay, it basically identifies our independent and dependent variables, right? Effect of frequency of practice, right? And we're also measuring archery score, so that kind of identifies our dependent variable. But you can also see that we're identifying our participants by their skill level, right? So they're either novice or intermediate, so that's another independent variable. Okay, it says we have 6 different groups of archers, 3 novice, 3 intermediate. Okay, so that'll tell you 6 independent samples, essentially, right? And then within each experience level, one group only practiced 1 day per week, one group practiced 3 days per week, and another group practiced 5 days per week. Thus, you can see we have 6 different groups in total. And you can see that in our Excel spreadsheet over here as well. Okay. And so this is usually how I'll give you the data, and then it's up to you to figure out how you want to further organize that data based on the information you've been given. So we want essentially to run an analysis to see if this effect is significant or not. Okay, so like I said, the first step is always to identify the independent variables as well as the dependent variables. Make sure you have the right types of data, and that will kind of lead you in the direction to understanding what type of test you should run. So the independent variables in this example are going to be frequency of practice. Okay. We're also identifying how many levels of each one. So this is going to be 3 levels, right? Or 3 groupings of this frequency of practice based on 1 day, 3 days, and 5 days per week. And this data is nominal. We could also call it non-parametric. I noticed a lot of you started shifting to non-parametric versus parametric, and that's totally fine. Either one is acceptable. Okay. When we look at, that's going to bother me. There we go. We also have our second independent variable, which is skill level. Oh, make sure I click that. Okay, so skill level, that's going to be 2 levels because we've got novice and intermediate, and this is also nominal or non-parametric. Okay, So this already gives us an idea that we have a two-way ANOVA because there are two independent variables being investigated. The dependent variable is archery score. That's what we are directly measuring, and that's going to be ratio. Some of you have put scale or parametric. Either of these are acceptable answers. When we look at the types of samples we've collected, you kind of have to break this down into how samples have been collected for each of the independent variables. So when we look at frequency of practice, we've separated our individuals, right, in the respect that there are different people in each of these practice groups. So we would say we have independent samples, or between subject design, right, for this one, since we have different people in each group. And then for our skill level, I think this one is pretty obvious that it's going to also be independent or between subject design, because obviously novices cannot also be intermediate. So if we look at how our samples have been collected, we already know we have a two-way ANOVA, and there are a lot of different combinations that we can use to label these. So the first way is to look at the various levels that you have. In a respect, we could say this is a 3x2, hold on, we could say it's a 3x2, call it independent factorial ANOVA. We could call it a 3x2 two-way independent, I can't spell, ANOVA, right? So there's a lot of different ways that we can phrase this, but we can also refer to this in respect to the types of samples that we have. So we could call it a two-way between ANOVA. We could even use the 3x2 between. I think personally that one or this one would be my favorite. But I mean, like, you could see there's so many different ways that we can write this. So my advice is to pick the way that resonates with you and then kind of stick to that for your notation. But we have 3x2 referring to the number of levels of each of our independent variables, right? And then we have the samples that correspond with those independent variables, right? So we have between, and then basically we want to look at what are the null hypotheses for the effects of the test. Now remember, when we have a two-way ANOVA, there will be 3 total main effects that we'll be looking at. These are separated from the assumptions that we have to meet, which is probably another thing I should have added on here. And of course we can add that into our discussion, but those are listed in the PowerPoint for your reference. But there should be 3 essentially null hypotheses. So you have a main effect for each of your independent variables, which is going to be read very similarly to if you ran a one-way ANOVA for each of those independent variables. And then you're also going to have a null hypothesis for the interaction effect between those independent variables. So the first main effect that we'll say we're going to look at is the main effect of frequency of practice. And then we'll also have a main effect of skill level. And then we'll have the interaction effect. And I'm going to type it this way, where I'm just going to put frequency and skill. Okay, so this is the notation that SPSS will use, and that's something that we mentioned in the lecture video. But like I said, each of these has a null hypothesis, and if each of these has a null hypothesis, that also means they have a p-value that will evaluate if that null hypothesis should be accepted or rejected based off of the mean differences between groups. So the null hypothesis for the main effect of frequency of practice is basically just going to say that frequency of practice has no significant effect on archery score. Okay. Similarly, when we look at skill level has no significant effect on archery score. Okay, you could also phrase it if you like the difference between the means wording, totally fine. My preference is identifying effects, so either way works. In terms of the interaction effect, we would say that, and you can order this in any way that you want to, frequency, or maybe the better way to put this is there is no significant interaction effect between frequency of practice and skill level in terms of archery score. Okay, and we dive into this interaction effect when we start looking at our post hoc tests. So when we have identified all of this information, we can then deduce what are the assumptions that we have to meet. And we basically, by doing this, we've made a checklist of all of those assumptions, with the exception of our wonderful homogeneity of variance and our sphericity. There we go. Okay, so remember, in any case, whether it's a one-way or two-way ANOVA or an independent or dependent t-test, whenever you have independent samples, you always have to test for homogeneity of variance. If you have repeated measures, right, in a t-test, in a paired t-test, we looked at the R correlation coefficient, and a repeated measure is one-way ANOVA, we looked at sphericity. And those assumptions carry over for a two-way ANOVA. You're just applying that particular assumption test to the variable that it matches. So since we have two between subject or two independent samples collected for each of our independent variables, that's going to dictate that we're going to have two assumptions of homogeneity of variance, one for each of our independent variables, right? Because we'll be comparing groups in various ways. So now we come to what to do with the data, right? Because remember, in SPSS, whenever we stick the information in, each row represents one subject, and we know that technically we have 6 different groups of people, so therefore we need to make a legend, right? And this is going to be based off of practice frequency. So maybe for practice frequency we have labels 1, 2, and 3 regarding 1 day, 3 days, and 5 days a week. And then we can also separate our skill level. And I can't spell. Oh my goodness. You guys, typos are the devil. Alright, so we could also label these, 1 and 2. And this would be novice, and we would have intermediate. I'll just put enter. Okay, so 2 different sets of labels. Each value, again, isn't a numerical quantity, but rather it represents a label, right, or a numerical label. So then what we can do is we could say we're going to have a column for practice frequency, we're going to have a column for skill level, and then we're going to have the actual archery scores that were measured. Okay, so that's where we have to start making sure that we organize everything such that we have one value per row, representing one value per subject. Okay, so when we look at practice, let's start with our 1 day per week people. And let's start with our novice skill level. So they're going to have a label of 1, 1, right? And that would be this group of data here. So we're going to copy that and we're going to paste it. Okay, and then we can copy these labels to match this set of data, right? And then maybe we do 1 day per week and the intermediate skill level. So that would be this set of data. Right, we can copy and paste. And then basically you're just going to do this for each number combination. So then we say, all right, we have 3 days a week for novice groups. And we're going to use this data. Right, and then copy our labels. And then we'll have 3 days a week intermediates. Hopefully this is making sense. And then again, copy our labels. And then we'll switch to 5 days a week, which is label 3 for novice. So you can see there's kind of a pattern that's emerging here. Whenever you have a between subject design, you usually have to make data labels. And then you have to sort your data into a big column. Okay, so we're almost there. And then after we have this data, we can copy it, and then we can go to our glorious SPSS and paste it in, and then we'll run our analysis. So while that's opening up, what I wanted to do with this is kind of do something similar to last time, where we're combining discussion of flowcharts with our examples, because you can already see it gets very complicated very quickly. So I'm going to kind of keep this on the side and then use it as a reference point for how you might use it when you're going through your outputs. So there's a lot going on this screen right now, but hopefully this will make sense. So we have our data copied. I'm just going to paste with my variable names. And then as always, we have to go to our variable view. We need to identify values. So for practice, 1 was 1 day per week. And then 2 was 3 days per week. And 3 was 5 days per week. For skill level, 1 was novice, and 2 was intermediate. We need to change both of these measures to nominal. Okay, there we go. And then make sure our archery scores scale, so that matches or agrees with how we classified our data already. And then from here, to do a between two-way ANOVA, we're going to go to Analyze. And then we're going to go to General Linear Model. We've seen this before. And then we go to Univariate. Okay. So you can see there's a dependent variable box. That's pretty obvious. Archery score is going to go in there. And then our fixed factors are basically our independent variables. Okay, so we'll put practice and skill in that box. And then because we have 2 between subject factors, we need to run post hocs for both practice and skill. And similar to before, we'll use a Tukey's post hoc test. So we'll press continue. Estimated marginal means is if we wanted to use a Bonferroni. And actually, I'm going to do both of these. I think in my I can double check. I think I closed it out, but I think in your guys's lecture this week, because I'm doing this prematurely, so I'm assuming that I put it in there. In your lecture this week, I list steps at the bottom of your thing here. So I just have compare main effects. So I think I also specify this in your module outcomes. This comes directly from your cheat sheet. I just want to make sure I have consistency with what I typically use. And generally, Tukey's and Bonferroni should give you relatively the same results. So this is kind of what you would refer to as far as like special notes areas. So post hocs, typically I go for Tukey's, but we could also use estimated marginal means, and that will give us our interaction effect. So let's do both, and then we'll look at the differences between the two, because I don't think that really hurts us in any way. In the options section, we have to make sure we have descriptive statistics, and we also need to make sure we choose our homogeneity test, because we have two between subject factors. We definitely need to make sure that Levine's test is included. Another thing I usually like to include is estimates of effect size, but this is typically because if you want to see what is the actual magnitude of the difference, that will give you an idea of how large the mean differences actually are. But other than that, that's kind of all we need to do. And then you can see this lovely long, yeah, it's a lot. So, if we kind of split this up, you can see this legend looks very similar to what we put in Excel. And it tells you what your sample size is for each of your groups. Our descriptive statistics give us our means and standard deviations. And then you can see our Levine's test here. Okay, so we have to kind of take this stepwise approach to reading the output, and that's where the flowchart comes in. So I'm going to pop over here. So you can see the first thing when we get to our output is we look at Levine's test, which is booyah right here, and we do it based on the mean, per usual. Okay. Remember, Levine's test has a p-value, thus the p-value is assessing a null hypothesis, which all of you should know now is looking at if a sample has equal variances, right? Or samples have equal variances. So the null hypothesis for Levine's test is that we're assuming we have equal variances, right? In this case, our p-value is greater than 0.05, so we would accept the null hypothesis and say we have equal variances. Right? And so then we can go straight to our test of between subject effects, right? Which you can see is the exact title of this box here. And this will look pretty similar to the ANOVA tables you've seen before. There's just a little bit more information included in here. So the main thing you want to look at is find the names of the variables that you included. So we have practice, that'll be the main effect for practice, right, or main effect of variable A. We have skill, which will be the main effect for variable B. And then we have practice times skill, which is our interaction effect. So each of these is going to have a p-value and thus a course of action that we will follow after we have kind of looked at our values. So in this case, what I like to do first is look at the main effects, right? So for practice, we can see we have a p-value less than 0.001, so that's a significant effect. So kind of check off this box here. Skill also has a significant effect, and so does the interaction effect. So usually what we say is if any of these three, and you might not always have all of them significant, sometimes there's only one that's significant, sometimes two are and one is not, just kind of be prepared for anything. But similar to one-way ANOVAs, when you have a significant effect or interaction effect, you then have to look at your post hocs. And I've highlighted, so I guess this is the way that we're going to go for this semester. I think I've tried it many different ways in past semesters, and the estimated marginal means is the way to go. So we can definitely look at Tukey's post hoc tests, but they're basically going to give us the same information as estimated marginal means, and the estimated marginal means are going to be, that'll be the same process that we use for repeated measures. So I think that's why I did that in hindsight. But basically, you only look at post hocs or accept post hocs if you have 3 or more levels. So when we look at practice, we have 3 or more levels, right? There's 1 day versus 3 days versus 5 days a week. For skill level, we only have 2 levels. And remember, post hocs or pairwise comparisons are basically the same thing as t-tests, right? Where you're comparing 2 different samples to each other, and then you're just switching what pairs you're investigating. So usually when we see a significant effect for a variable that only has 2 levels, we accept the p-value for what it is because we would get the same p-value if we looked at pairwise comparisons. Hopefully that makes sense. But basically, once we find out if we have a significant effect or not, we can then look at our estimated marginal means. Now, before you get too far into your output, the first thing I always check on is, do we have a significant interaction effect? If the answer is yes, you stop where you are and you redo the output. And this is why. Because you see this portion up here, it's technically in the log area. This is where your syntax is located. So if you double click on this, you should be able to highlight all of the information in it. So basically this represents the code that's put through the program so that it knows what functions to run. So once you copy that, you're going to go to File, you're going to go to New, and you're going to go to Syntax. This will open up a syntax box, and you just paste everything that you copied from this original syntax, okay? And then basically what I do so that I don't get confused is I will delete, if I can minimize some of this stuff, I basically delete, oh man, it won't let me do it all at once. Okay, I'll delete everything that is in this output because when I rerun this test, it's going to give me, oh, that's the easier way. It's basically just going to spit out all the same information and it doubles the length of your PDF, and that is not fun. So you'll see down here, we've basically got like our compare, pairwise comparisons information here where we're adjusting with the Bonferroni, right? And that basically gives us our pairwise comparisons for practice, pairwise comparisons for skill, and then you can see we have our interaction effect here. So this is where we have to edit the syntax. We're going to put compare, and then we're going to put parentheses, and then basically you just pick either practice or skill. I'm going to pick practice because that was first. And then you're going to put ADJ Bonferroni. Okay, make sure you spell it right. And then you're going to press enter. And then all you're going to do is copy that line, paste it in the line below, and then change out the variable you put in the first time with the other variable. So basically what this translates into is that in this one, and it'll make more sense when we actually take a look at the output, but this one you're going to be comparing practice levels within skill. So kind of looking at is 1 day, 2 day, or 3 days a week significantly different from each other when we just look in a novice category versus when we just look in an intermediate category. And then vice versa, we'll look at skill level within the practice days. Okay. Visually, I think it makes more sense when we look at the output. But the other thing to make sure that you pay attention to is that the data set is in accordance with the data set that's open. So you can see data set 0 is my current active data set, and make sure that's listed here. If you have a lot of data sets open, it's very easy to apply the syntax to the wrong set of information. So basically, once we get this figured out, we press play, and now you can see, look at this. We have 2 areas for our practice skill interaction, and I'm going to get rid of this one down here because I decided we didn't want to use it. So basically, after you finish editing your syntax, you can close it out. You don't have to save it because it's kind of saved in this already, right? And you should see that as far as your results are concerned, right, these p-values are still the same. We're just now looking at pairwise comparisons. You can see which days or which practice frequencies were significantly different from each other. So those would be your post hocs for main effect A, or frequency of practice. Again, you could look at the mean differences or p-values between skill level, but again, the p-value is going to be exactly the same as in the main effect table. But that would be your pairwise comparisons for main effect B. And then last but not least, we're going to look at our interaction effect. So the first one that we put in, again, remember we said we're going to look at practice or compare practice, and we're going to see how skill level differs when it's in practice. Okay, so when we're going to look at practice within skill level. So remember the word or variable that you place within the parentheses after you put compare in the syntax is going to be what you're actually comparing. Those are the pairwise comparisons, but it's going to be within the groups of the other variable. So in this respect, you can see that most all of our pairwise comparisons for our interaction effect or simple effects are significant, with the exception of intermediates between their 3-day and 5-day per week practice frequencies. Okay. So this is potentially valuable information depending on, you know, like what your research question is, because we could look at, say we're looking at practice, right? These results negate skill level entirely. So it's just saying, right, 1 day is significantly different from 3 days. 1 day is significantly different from 5 days. But this comparison does not discern between our skill levels, right? So when we look at the interaction effect, we can say, well, is there a particular group in which 1 day is significantly different from 3 days, or 1 day from 5 days, or 3 days to 5 days? Right? And you could see that all of these pairs are significant for novice people, but not all of the pairs are significant for intermediates. So that's where kind of the value comes in with interaction effects. And the way that you phrase your interaction effects are based on your research question. For our class, we always look at both. And so like flip side, right, if we look at the interaction effect when we said compare skill, right, so novice to intermediate within our practice frequency, we can say, well, in the 1 day per week frequency, how different were novices to intermediates, right? And then we can see all pairs are significant in this case. But that kind of sums up the between factor effects, and I've kind of oops, I did not mean to move that. I've kind of summarized down in these pairwise comparisons areas, right, how you would kind of interpret these pairwise comparisons. So again, the way that they're listed is highly dependent over here. So let's say that only one pair was significantly different, just for the sake of example. When you report it, you could say that novice is significantly different from intermediate skill levels within 1 day per week practice frequencies, right? Continue on if there's other significant pairs, but that's kind of how you would word that. Or you could say skill level has an effect on archery performance in a 1 day per week practice frequency, right? Somehow kind of wording it back to you're looking at the interaction of one independent variable within another independent variable. All right, so that's our between factorial and ANOVA. That was a lot of fun. A lot of this is repetition too once we get into other examples. So what I'm going to do is minimize this for now and minimize that for now and go to our next example, which is problem 2. Yay! All right, so we say participants were put into different training programs to see what differences in VO2 max might occur from undergoing different types of exercise. Participants were assigned to a mode of exercise, and then each participant's VO2 max was tested using 3 different protocols. Okay, so this kind of tells you automatically mode of exercise is going to be one of our independent variables, and you can see here we've got running, cycling, or rowing, and then each person, this is key, each person is tested using 3 different protocols. So that means there are 3 measurements per subject, right? So when we look at this in terms of our independent variables, we've kind of highlighted this already, right? But we have mode of exercise. We've got 3 levels based on if they're running, cycling, or rowing. And we know this is nominal data. I'm going to keep it at that. And then we also have protocols, which also have 3 levels, and which are also nominal, right? Because they are based off of treadmill, rowing machine, or cycle ergometer, okay? Our dependent variable is going to be VO2 max, because that's what we're directly measuring. Oh yeah, I want color, and this is ratio data. Based on our samples, again, you have to figure out how each independent variable was looked at. So in terms of color, mode of exercise, okay, each person was assigned to a mode of exercise. So that means this is going to be a between subject sample, or 3 different samples. And then when we look at protocols, we already identified that each person was tested using each of the protocols, right? So that'll be a within subject type of sample. And this gives us information, right? We're going to have a 3 by 3 because that's indicating the levels. So we can either use the 3 by 3 or the 2-way notation. And then we're indicating that we either have a mixed, or you could type between, within, basically ANOVA, right? Again, many different ways that we can type this. Choose the way that you love the most, okay? And then we have to look at what the null hypotheses are for the effects of the test. So again, 2-way ANOVAs have 3 main effects. We're going to have our main effects of mode of exercise. So basically saying that mode of exercise has no significant effect on VO2 max. We're going to have a main effect of protocol, and that's basically saying that protocol has no significant effect on VO2 max, kind of regardless of the type of exercise people went through. And then lastly, we look at our interaction effect, which is going to be mode and protocol. And basically that says there is no, you put significant interaction effect between mode of exercise, there we go, and protocol. Alright, add in terms of VO2 max. Alright, so remember we're always relating, even though I give you guys kind of formulated phrasings for, you know, IVA, IVB, DV, make sure you tie back in the variables pertinent to the example into your wording. Okay, so we have our information. We know for between subject variable, we're going to have to look at homogeneity of variance. For within subject variable, we have to look at sphericity. So, and then we also have to evaluate, is this data organized the way that it should be, right? We know for between subject factors, we have to create data labels. So I'm going to do that over here. Okay, let's say that we have 3 different modes of exercise. Let's say 1 is running, 2 is cycling, 3 is rowing. And so basically we're going to have a column for mode, and then we'll have our protocol, that's the word. Okay, so we'll have Bruce rowing and cycling. So for ease of labeling, I'm just going to copy and paste those in here, and then make it look nice. Okay, so mode identifies our between subject groups, right? So I'm going to look at my running group first. That's these guys here, and basically I'm just copying and pasting their data, right? Because each person was measured 3 times, so all of them get a data label of 1. And then I'll look at my cycling group next. Again, copy their data, stack it in. Okay, so you can kind of think of it in terms, the more repeated measures you have, the more columns you'll have. The more between subject measures you have, the more rows you'll have. However, it sticks with you. Okay, so then we're going to copy this information. I'm going to minimize this for now. And I'm going to open up a new data sheet. I'll go ahead and minimize datasheet 1 so that way the program doesn't get confused. Same old, same old. We gotta adjust our values. So 1 we said was running, 2 cycling, and 3 was rowing. Again, make sure your measures are representative of what they actually are. And this is the one thing, whenever you put in repeated measures, values, remember that the values in the data set that are represented here, that is what you're classifying, right? So we do have a within subject categories here, whether, based on the type of protocol that they were involved in, but the actual values that are in the columns are ratio data. Those are the actual values that we measured, okay? In terms of the mode of exercise, this is going to represent, again, numerical values that are labels. So they don't have any quantifiable weight. Okay, but once we have this information in here, we go to Analyze. Anytime you have a repeated measure or within subject variable, you have to use repeated measures. Okay, rule of thumb. And then this part should look familiar to you. You put your within subject factor first, so the one that had the repeated measures, which was protocol in our situation. And there were 3 levels, right? Bruce, rowing, cycling. So we define those. And then it's very similar, just kind of ignore mode for right now, but it's very similar to how you would have put in for a one-way ANOVA, right? You just pop everything over into the within subject area. And then you'll see we have this between subject factors. Whoa, that's where it comes in, right? Mode is our between subject factor, so we put that in there. Very similar to what we've done in the past. We're going to go ahead and input all of our variables so that we're looking at main effects as well as interaction effects. And then in our options, again, descriptive statistics, we definitely need homogeneity tests because we have a between subject variable. If you do not have a between subject variable, you don't have to click this box. Okay, but that's not the case for this example. And you'll see we get, I'm going to relabel these so I don't get confused. Because the last thing you want is, like I said, when you adjust the syntax, you delete stuff. The last thing you want is to delete the wrong one, because then you have to run the test over again. Okay, but very similar to before, and I'll go ahead and pull up our flowchart. We're looking at a mixed. So in this case, we have to look at 2 assumptions before we can look at the main effects for those assumption tests, right? So descriptive statistics, all well and dandy. And then ignore this for now. Ignore this for now. And look, Machi's test, that's the first one. Yay! Okay, so we evaluate Machi's test. And same thing that we've done before, we're looking to see if there are equal variances between the difference scores between samples, right? So if we have a p-value greater than 0.05, that means we have assumed sphericity. And look at that for protocol, which is our within subject variable. We have a p-value greater than 0.05, so sphericity is assumed. And then we can look at the sphericity assumed row, and we can see the significance of our main effect for protocol is less than 0.001, therefore less than 0.05, right? We're looking at tests of within subject effects for main effect A, which is our within subject effect, right? And so p-value is less than 0.05, which means we're definitely going to look at our post hocs for that variable, or for that effect. You're also going to notice, right, test of within subject effects, that you're going to have a second p-value for your interaction effect. So again, I always encourage you guys, look at this first to make sure that you're correcting the syntax before you get too knee-deep in your analysis. Right, so in this case, we do have a significant interaction effect. So that tells us, go back to the log. We're going to copy the syntax. We need to generate a new syntax. It's going to be matched with dataset number 1, but we basically are going to do the exact same process we did before. So we're going to compare, let's do mode first, ADJ, Bonferroni, right? Basically copy and paste. Change mode to protocol. Whoops. Oh goodness. Protocol. There we go. Right, hit play, and we generate a new one. So this is the one that I'm going to call my between within, and then this one I can delete because I don't need it. Okay. So we can go back to our test of within subject effects. So we know we've kind of checked off two main effect evaluations. We've looked at the main effect for protocol. We've also looked at the main effect for our interaction effect. Both of them had p-values less than 0.05, which means we're going to be looking at post hocs for each of those. Now we have to look at our between subject variable. So this is where you scroll down and you see, oh look, hey, it's Levine's test, right? And you'll see that you have, and this is sometimes confusing to people, but you're going to have three different homogeneity and variance values. And I'll tell you the reason why. Because when you look at each, it'll be in terms of the protocol, because that's the within subject effect value per se, right? So we already checked the sphericity for the within subject effect thing, right? This one we're looking at mode of exercise, but we have to look at it in terms of, is mode of exercise, do we have homogeneity of variance of the mode of exercise within each of our different protocols? So basically, Bruce protocol, this is going to be comparing the variances of the running, the cycling, and rowing groups, only looking at this protocol's values. Okay, same thing with the rowing machine. So we have to make sure that each of these meets our assumption. All of them are greater than 0.05, so we can wipe the brow off and say that we have equal variances, but that's why these protocols are listed, is because each of those are separated based on the mode of exercise. So you'll have three to evaluate. Usually they're all going to be the same. If they're not, that probably indicates you have some outlier, or maybe two different sample sizes. Okay, but in either case, we say we have assumed homogeneity of variance. If we assume homogeneity of variance, we then look at our test of between subject effects. Hey, look, test of between subject effects. And we have our mode, right, our mode of exercise. So we have a p-value for mode of exercise, and we can see that there is no significant difference. Or there's basically, when we look at all the means, there are no significant pairs within that mode of exercise. So when we look at these, right, or estimated marginal means or pairwise comparisons, that should confirm no significant differences, right? So it's not necessary to look at post hocs for our main effect of B, since we accepted the null hypothesis for the main effect of B, or mode, right? So really all we're concerned with is our main effect, or post hocs pairwise comparisons, right, for protocol and for our interaction effect. So that's where toggling through this part kind of helps. Okay, so for protocol, remember our labels. 1 was the Bruce treadmill, 2 was the rowing, and 3 was our cycle ergometer. And then we can see that when we look at protocol alone, independent of the mode of exercise, that we had significant differences between each of the protocols. Okay. If we look at the interaction effect, however, remember the first one that we entered in was looking at mode within protocol. So within the Bruce protocol, which modes of exercise had significant differences, right? And in this case, we could see running and rowing were significantly different from each other when considering the Bruce protocol on the treadmill, right? When we look at the rowing protocol, there are no significant differences between groups. And when we look at the cycling protocol, there are also no significant differences between groups. So hopefully this is kind of starting to click a little bit. Again, we can reverse the situation and say, are there any differences in protocols when we look at the mode of exercise, or when we're within the mode of exercise? So within the running group alone, did they have significantly different mean values of their VO2 when they had a different protocol? And we can see pretty unanimously, except for in the cycling group, specifically protocols 1 and 3 and 2 and 3 were not significant, right? But again, significant differences are going to be indicated between protocols within the mode of exercise, okay? So that kind of wraps up our example for our between within 2A ANOVA, and that brings us to our last practice problem, which has to be a within factorial ANOVA. Okay, so I'm gonna again minimize my SPSS deliciousness. I'm just gonna keep that there. Minimize lecture data. All right. What is the scenario? Isn't that a song? Pretty sure that's a hip-hop song. All right. So we have researchers are interested in seeing if interval training has an effect on heart rate at different time points of exercise. So automatically we could see two independent variables, right? Interval training, because we're looking at the effect of interval training, right? So we have interval training, heart rate is what's actually being measured, and time points of exercise would be our other independent variable, right? And we can further look into our scenario to kind of figure out more information about how our samples were collected. So we have participants were asked to run on a treadmill continuously on day 1 of the study and alternate between 1 minute run and 1 minute rest intervals. On day 2, they came continuously running on day 1, and then the intervals come in on day 2. There we go. I confused myself. Okay, so heart rate was monitored every 4 minutes for 20 minutes, which would give us 5 time points, right? Run an analysis to see if an effect is present. So I kind of already hinted at what our independent variables are. So this would be intervals, right? So there's 2 levels here, in the sense that we have a control group, which has just continuous running, versus our 1 minute run, 1 minute rest. And this is going to be nominal data. Our second independent variable, as we said prior, is time points of exercise. Okay, and we can confirm with this one, we've got 1, 2, 3, 4, 5 time points, because it's 4 minutes for 20 minutes, so this one would have 5 levels. Also nominal, because we're categorizing by time, right? And then dependent variable we identified as heart rate, and that's ratio data, right? That's the actual measured data in each of these columns. So then we have to determine how each independent variable was collected. So for our intervals, right, it appears that each person came in to be collected twice. Once on day 1, they did continuous running. On day 2, they did the interval running. So that means we have a within subject design, right? We use the same subjects for each of our groups. Then we have time points. Clearly this one's a within subject, because once you have someone running, it's not like you can switch them out with a different person. Okay, so this will be our within subject. Okay, so when we come down to it, we can identify the type of factorial ANOVA we're using by either identifying the levels, right? So we could call this a 2x5 or identify it as a 2-way. We could call it repeated measures, or we could also call it a within ANOVA. right? In either case, you're either going to want to use the level method or two-way, and then you choose between repeated measures or within. Okay? Pick your favorite combination. But again, similar to our previous examples, we're going to have, or in a two-way ANOVA, we have 3 effects. So we'll be identifying the main effect of the intervals, basically saying that interval training has no effect, no significant effect on heart rate, right? That's gonna bother me. And then we're also gonna be looking at the main effect of time points. Okay, so basically time of exercise, I guess we could word it as, has no significant effect on heart rate. And then lastly, we'd be looking at the interaction effects. Oh, good Lord. Right, and this is going to be between interval and I'm just going to put time. But basically saying there is no significant interaction effect between interval training and time points in terms of heart rate. Okay. So we've got our information. We then say, do we need to reorganize the data? Right? Because each of our rows needs to indicate one subject. And in this case, we said each of our independent variables used the same subjects. That means each person should have 5 time points for continuous training as well as 5 time points for their interval training. So when we reorganize this, again, remember I said when you have between subjects, that's going to give you more rows because there's more subjects. When you have within subjects, it's going to give you more columns. And we're going to have to slightly change how we label things. So I'm going to label continuous training as CT. And we'll look at this as CT 4 minutes. We'll have CT 8 minutes, CT 12 minutes, CT 16, and CT 20. We then continue on and we'll do our interval training. So I'll put IT 4 minutes, IT 8 minutes, IT 12 minutes, IT 16, and IT 20. So that indicates, again, 5 time points per type of training, right? And then the fun thing with this is we just copy and paste. Copy and paste. It's amazing, really. And then we copy and we paste, right? So we need a new data set. La 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 la. I'm gonna minimize that one and we can paste our variable names. Again, all of these are gonna be scale. Even though they represent different categories, each of these values represents ratio data. Okay, so remember, whatever is in the columns needs to be what the type of data is. So that aside, I'm going to minimize my spreadsheet because I don't need it. We're going to go to Analyze. Remember, anytime you have repeated measures, you go straight to the repeated measures test. And here we're going to identify our within subject factors. So we have our interval training. There were 2 levels, right? Basically control group versus actually doing the interval training. And then we have our time. Number of levels would be 5, right? Because we're measuring every 4 minutes for 20 minutes. So we define those 2. And then you can see in here that we've got these labels that look like 1, 1, 1, 2, 1, 3. What do they mean, right? So if you look at this notation, right, we have a certain format in which we're inserting variables. So you can see the first value listed here is going to indicate the interval, while the second value indicates the time. And if you put things in correctly, right, as far as interval goes first, time goes second, then you should be able to insert all of these at the same time, right? Because we could say continuous training has a label of 1, 4 minutes has a label of 1, 8 minutes is 2, 12 minutes is 3, 16 minutes is 4, 20 minutes is 5, right? And if we're doing all CT measurements, so all a label of 1, you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, right? And then we switch to 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. So that's how that works. There's no between subject factors, so we can skip that. We go straight to our estimated marginal means, stick everything in, do our normal. Our options, you don't need homogeneity tests because there's no between subject factors. So we can click continue and press OK. Right, and so then in our general linear model, again, we get our descriptive statistics. Don't look at multivariate tests, don't need them, right? So I guess we can consult our flowchart. All right, we're going to start with Mauchly's test, assuming that we've met all of our other assumptions. So you can see you're going to get Mauchly's test for each of the variables because they're all within subject, right? Now, there's one important thing I want to point out that hasn't come up yet in this class, but Mauchly's test only is run when you have 3 or more levels. So you'll notice that intervals doesn't have a p-value for sphericity. And the reason is because there's only 2 levels of our intervals, right? Either control group or they're doing the interval training. So in these cases, when you only have 2 levels of an independent variable, you assume that you've met sphericity. Okay? In the other cases, we have time, which also sphericity is assumed. When we look at our interaction effect, sphericity is not assumed. So then this case we would follow the greenhouse geyser epsilon evaluation method, where we say if greenhouse geyser epsilon is less than or equal to 0.75, we use the greenhouse geyser adjustment. So when we look at our test of within subject effects, right, we're assuming we've met sphericity for both our main effects, but we have not met sphericity for our interaction effect and therefore must use the greenhouse geyser adjustment. Okay, so when we look at intervals, we can see we have a significant effect, right? P-value is less than 0.001. When we look at time, again, sphericity assumed, significant effect. When we look at our interaction effect, greenhouse geyser, we get a p-value of 0.033, significant effect, right? So all of these have p-values less than 0.05, therefore we look at our pairwise comparisons. Okay, specifically looking at pairwise comparisons for our time points and our interaction effects, because intervals, again, there's only 2, that's basically a t-test, so we don't really need pairwise comparisons for those ones. But because we do have a significant interaction effect, that does mean we need to change the syntax. So I'm going to pull up my syntax here. I'm going to go back to my log for this test, and I'm going to copy and paste that syntax in here. Again, we go straight to our interaction effect. So I'm going to do compare intervals with my Bonferroni. Okay. Oops. Oh my goodness. Copy paste. Change intervals to time. Make sure we're on data set number 2 and go ahead and run it. right? Which means this one is my within, and then we can delete this other one, because that would be redundant, right? So within, again, we've already looked at Mache's test. We've already looked at tests of within subject effects. We've identified that every single one of our variables, our main effects and interaction effects, are significant. Again, I said because we only have 2 levels of intervals, we don't need to look at our pairwise comparisons for that one, but we should look at the pairwise comparisons for time. Right? And in this example, we can see we have all significant pairs except for between time points 3 and 4, and I think that's it. So likely what happened in between time points 3 and 4, and this is where you kind of go into your extrapolation of your analysis, is like maybe that was a steady state, and people reached a steady state between time points 3 and 4. Speculation, we don't actually know. But the thing is to remember is that when you look at this, right, if we come back to our data, we're basically saying, let's look at the time point, so whether at 4, 8, 12, 16, or 20 minutes, irregardless of the type of training they did, if intervals were present versus intervals were not present, right? So, again, the main effects give us information, but they don't always give us the information we quite are looking for when we're doing our full analysis. So if we look at our interaction effects, the first one we said we wanted to compare intervals within time points. So this basically says, does our continuous running versus interval running, are there significant differences at 4 minutes? And are there significant differences between the two at 8 minutes or at 12 minutes? Right? And we could see there are significant differences only at the 4-minute time point and at the 16-minute time point. Right? So phrasing, if you're kind of practicing or thinking about how you would word this, as we'd say there are significant differences between continuous running and interval running at 4 minutes and 16 minutes of a 20-minute bout of exercise, right? Or significant difference in heart rate at blah, 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 okay? So that's one set of interaction effects, and then we know we had another set where we're looking at significant differences between time points within if we had continuous running versus interval running, okay? And the process, again, is pretty similar. We can see that most of these have significant effects except for time points 2 and 3. Those were not significant. Time points 3 and 4 were not significant. And I think that's it. At least for interval 1. So in continuous running, right, we had mostly significant differences between our time points with the exceptions of the 2 I just mentioned. And then when we look at interval running, we could see that there were significant differences between heart rates for pretty much, again, all of these pairs except for time points 3 and 4 and 3 and 5, okay, as well as 4 and 5. So that kind of sums up our within type of test. So really what I wanted is you guys to understand how to use the flowcharts with the outputs. I think, again, it's really helpful. But using this practice information, and as always, I highly recommend using your key terms and concepts module. I need to change the number on this. I'll update that. But basically, I have step-by-step as well as the assumptions you have to meet, any notes on the types of tests, right? These are what are included in your Excel and SPSS cheat sheet. I even give you how to adjust the syntax, right? So make sure you utilize your resources with that respect to that document. And then basically what I've given you guys is you have your data set. Okay, so for each of our examples in here. And I basically just give you a scenario, so it's up to you in the activity to decide, do I need to reorganize my data based off of the types of variables I have so that they go into SPSS correctly? And then, did I keep the answer sheet up here? Apparently I took it away. But in your answer sheet, basically you're going to label using the level method, right, like 2 by 3 or 3 by 4, okay? So list how you would classify your two-way ANOVA based on the levels of the independent variables, and then identify if it's a between, within, or within in these two boxes here. And then you're basically just going to answer questions off of the output that you got, okay? Now, I do realize that if you choose the wrong test at the beginning, you're kind of screwed with the rest of your answers. However, if you, because I check everyone's output, so if your output values agree with what you write, and if what you write agrees with the test that you chose, you still get points down here, but you'll just kind of miss the first 2 points based off of what test you chose to run. So you're still applying and getting rewarded for the correct application. It's just making sure you look a little bit more carefully at how each of these would be classified in terms of if you have a between subject independent variable versus a within subject variable, because I think that's the biggest complication in two-way ANOVAs. But you've got 3 examples to work through. You're only going to use each type of two-way ANOVA one time. So you'll have one within, one between, one between. Hopefully that helps you out a little bit in terms of deduction. And then all you're going to submit is your completed answer sheet and your output. Okay, in total this should be 40 points. There we go. Okay, it used to be 30, but I upped the ante. So 40 points total due by next Monday at 11:59. And if you have questions, please let me know.